Hey everybody, welcome, good afternoon, good morning, wherever you are. My name is Dave Glover. I'm a cloud advocate, actually based in Sydney, Australia. So it's a rather chilly morning and pretty early here too as well. So hopefully I will stick with you. This session here is, I think, probably the last session in the series for the MCP days. And what it's going to be talking about is unlocking really the potential of agents using something called the Azure AI Agent Service, MCPs, which hopefully you've learned lots about, and we're going to be using Postgres as a backend database. As I said, my name's Dave Glover, and you can see my LinkedIn and GitHub accounts there. Now, I will have a link at the end to the resources for this session as well. So the source code and things like that, and documentation for you to play around with. So just a very quick overview of the use case for this. Someone might have already used this use case, but effectively what we're going to be is we're going to be a DIY company, and we're going to be doing some sales analysis. And we're just going to be using an agent to do that. We're just going to go through some of the processes of how you can use agent service and how you can use MCP, in this case, Postgres, to be able to support that. You've probably seen many definitions for agents, but think of them as semi-autonomous software. I give them a goal, and the large language models will figure out what needs to happen to accomplish that goal using a series of tools. So in this case, with tools are going to be provided by MCP. It could be looking up databases, it could be kicking off an HR process, it could be kicking off a logistics process, whatever it is. In our case here, the tools are going to be really around data analysis. Okay, so how can MCPs help us? So if you think about the landscape and where we've kind of got to with the use of AI and agents at the moment, a great analogy, if you think about, we've all been used to building services, building solutions for businesses out of REST-based services, being like microservices and things like that. And there's specifications for doing that. You might have heard of things like Swagger or OpenAI specification and things like that. Those specifications have been around making REST-based services discoverable and calling on those services and providing authentication and all those types of things around them. So think about, we've got the Swagger or the OpenAI, the Open API specification for REST services. Well, think of MCP, the model control protocol, as a specification ready for AI agents, which is the same idea of being able to have a single specification to be able to call upon tools to provide context back into models. And that's fundamentally what it's about. So these kind of nice abstractions to make things easier and interoperable. What does that mean from a business perspective? Of course, it means in the same way we want to be able to build composable systems. So our businesses are more agile as our businesses grow or change. We can slot in different backend services. The same is true for building AI agents with MCP, where you're able to slot in different backend sets of tools to support your business. And that's kind of really fundamentally what the goal is behind this. So you think about at the moment, well, I guess we're getting less of the moment, given it's all pretty new. But if you think about lots of different scenarios and different clients who want to call upon backend services, and without some sort of standard behind that, everyone ends up doing it in bespoke ways. And of course, that just makes things really difficult from an integration, and just creates chaos and a lot of overhead. So the goal behind that, as I said, the same idea with OpenAI specification with MCP, is to provide a standard way in which you can expose context from backend services into your AI applications and AI agents. So it's an open protocol that standardizes how applications provide context to LLMs. And you've probably heard this analogy used plenty of times. It's a bit like the USB-C for AI, or the OpenAI for REST-based services. And what's the goal? The goal ultimately is to provide business agility. So you can choose the best context or tools to support your business. Okay, so what are we going to be building? We're going to be building, in this case, a simple chatbot, which kind of connects into the backend services via MCPs. and enables us to do some data analysis. Now, again, this could be a whole range of scenarios. It could be the HR system for this DIY company. It could be logistics. It could be a whole range of different scenarios. In this case, it's back office data analysis. And you may have seen some of these kind of scenarios before. And what we're going to do is we're going to start off a little bit with the end in mind, and we'll just fire up the application, and you get a bit of a sense of where we're going. And then we're just going to break this down, and you can kind of see how this all works. So we're going to fire up, start the solution. And over here on the right-hand side, you see I've got the basic chatbot, and you can come along here and you can come along and ask questions. It could be show sales by store. And what that would do is that that's talking to what's called the Azure AI Agent Service. And this AI Agent Service has a number of tools, in this case, MCP tools, that have been registered with it. And via those tools, it's grabbing the data out of a database and then returning it back to the user interface, back to the chat. In this case, you got show sales by store. Maybe you might want to say for last quarter. And the way this is working, so I'll just give you a bit of a high level view of what's going on. The MCP, there are a number of MCP tools. One of the tools is to bring back the schema of the tables that support these queries. So the large language model will say, okay, I've got these sets of tools. I need to know the schema of the database that I want to be able to get the data out of. It goes and asks an MCP tool for that. It gets back effectively a markdown document that describes what the schema is. The large language model then looks at that schema and says, okay, to support that question, I'm going to need to generate this SQL. And that SQL is then submitted to an MCP tool. That database that SQL query is executed and then returns back the data back to the agent, and then it's formatted, in this case, back as Markdown, back to the agent. Now, I just want to put in for last quarter. Now, you might be wondering, well, how does an agent know what last quarter is? And it's relatively straightforward in that there's an MCP tool, which is basically get the current date. And so that data is provided back to the larger language model, and then the larger language model can cater and customize the query, the SQL query, to go and get the last quarter. And you can see the last quarter here was April to June. That was the last quarter for data. So that's how that worked. And then you can come along here and say show as a pie chart. And what this is doing is this is using the code interpreter. So what's happening is a large language model has the context. It knows about the sales. We just asked it, so it knows about the last quarter sales. That's great. So it's got that context. And then what happens is that the large language model goes and writes some Python code to go and generate this pie chart. So it takes the data, which has already got the context inside the memory, and then provides that to the code interpreter, writes the appropriate code, and executes it. So I could say show as a bar chart, and it would go off and write the appropriate code. It's got the data, goes and writes the appropriate code, and then returns back a pie chart. Okay, so there we've got our pie chart. So that's kind of where we're going to go. And what we're going to do is just break this down as to how this is actually working. Okay, so we'll just pop back to the slides. And the first thing I want to talk about is the agent service and what it is. So it's the agent service is part of the Azure AI Foundry. So it's a specific service within that kind of family of or suite of services. And to kind of give you an idea how this works, the agent service has these concepts called agents. An agent is the scope of the application. A thread is a scope of a user conversation. Then you go and run these agents, and that basically looks at the thread to say, okay, the users asked, what were the sales by store? The agents interpret that, pass that across the large language model. The large language model takes that and says, figures out, okay, well, this person's asking about data analysis. I need to know the schema. So the large language model goes and grabs that, calls the appropriate tools, gets back the schema, goes and executes that data, and then returns it back to the large language model, and then formats it as markdown, and then returns it back to the chatbot in this case. And there's processes in here for checking the status of what's called a run, and displays that back. So we have the agent scope. In the agent scope, you have a set of instructions. We'll have a look at those shortly. So you've got instructions and tells the agent basically how to behave, and says, in this case, you are a sales analysis agent. You can look at what models. In this case, I'm using a couple of OpenAI models. And then we have a number of tools. In fact, there are quite an extensive range of tools. So the latest tool that's been added is the support for MCP servers. But there's also tools in there for things like file search. So you've got semantic search across documents. I've already mentioned the code interpreter, which that was the thing that was executing this sandboxed Python environment. So it's a secure, safe environment for executing a subset of Python. You've got function calling. So if you're familiar with OpenAI and function calling and things like that, integration with Bing Search, Fabric, Logic Apps, etc. And the idea being is you've got a thread, and the thread comes along and the user says, tell me the total sales by store. And what's going to happen is that the large language model is eventually going to say, I'm going to call this MCP server, and I'm going to query the Postgres database. I'm going to execute a query, and I'm going to return back that data back to the agent. And then the user says, show us a pie chart, which I showed you before. The large language model goes and generates the appropriate code to go and generate that pie chart. Takes the context, so it's already got the data back from the database, merges that together, and voila, you get the pie chart. So that's kind of how that works. Right. So what we're going to do now is just step through some of these how this works. So we've got our MCP server. So remember I said there are a number of tools. So I mentioned before that there was a tool in here which is called Get Multiple Table Schemas, or that is the tool. And the role of this tool is to return back the schema and the relationships of the tables to support the queries that the large language models will need to go and generate the appropriate SQL. So that's kind of what it does. And you can see in here, I'm actually telling it, I've actually sort of hard-coded the tables in the database, but clearly that could be done dynamically as well. You could have another tool there to go and grab the tables. And what this is ultimately going to do, it's going to call into the Postgres database, and it's going to grab the metadata for each of the tables that's required to support the question. And then we've got another tool in here, which is execute the sales query. So in this case, it's going to execute the select statement to go and grab the data. Now in here, we've also got the Postgres database is also set up with row level security. So you could pass in a header across into that tool. You could say, hey, look, this is the context. I want you have a limited subset of data within that Postgres database. It's called Postgres, they call it row level security. Other databases have similar concepts with maybe slightly different naming conventions. And you remember I said about last quarter, well, a large language model, they do have a sense of date. They do have some sense of time, but it's typically around when the model was trained or when there's a strong sense of a particular date, but almost certainly not the current date. Almost certainly with that. So all this is a tool, which is basically which is a tool the large language model can call. And surprise, surprise, all it's doing is returning back the current time in UTC format. Okay, so that's the tools we've got. And what I'm going to do is bring up a query. So no doubt you've already seen that inside Visual Studio Code, there is the ability to go and execute MCP service. So what I'm going to do is I'm going to fire up, we're going to debug this. We're going to start up my MCP server, and we're going to come across and we're going to paste in this query, which is basically telling it we're going to use the Java sales MCP. We're going to show sales by store for last quarter. And what I'm going to do is I'll go to the MCP JSON, and you'll see that I've already got this running. So let me just stop that, restart that, and we're now running. And you'll see that it's discovered the 3 tools that I just talked about. Okay, so we're in the chat, we're in agent mode inside VS Code. We're going to send that through, and you're going to see what's going to happen. You're going to see the large language model is going to figure out, well, I need to know the current, to be able to support this question, show sales by store for the last quarter. I'm going to need to know what the current date is. So I'm going to execute that, and we'll see back in the response, it's come back with the current date. Back up here, you can see that the current date is indeed the UTC time. It's the 30th of July. The next thing the large language model is going to need, it's going to need the schemas for the stores, the orders, and the order items table. So we're going to execute that. Okay, so if we just look what came back from that, you can see there goes a markdown document of the schemas, and you can see, like, okay, there's a schema for the orders table. It's got orders, store ID. You hopefully get the general idea. And we'll come down here to last, not but least, this is the SQL query that the large language model has figured out we need to execute. So it's going to call that tool, and we'll see the response coming back from the MCP tool. And there we've got the data out of the database. Okay, so that's just the MCP server running inside VS Code. And you might be wondering, well, how does that relate to the agent service? And that is the next thing I'm going to talk about. So we've got the main agent service. We'll just stop this executing here. So we've got the main, this is the main app. It's effectively a fast API app, or it is a fast API app, and it supports the chat. So the first thing you'll notice in here, we've got some instructions. And these are the instructions we're going to pass into the agent to tell it to how to behave. So we'll come over, and this is the instructions, and you can see, okay, here, well, this is the sales agent, the role, and you tell it, well, you're a sales analysis agent for a Washington State DIY retailer. You're going to help users answer sales-related questions. The financial year begins July 1st, kind of useful for the large language model when you're asking, hey, tell me what's our sales for the total for this financial year. And then I'm going to tell it a bit about the tools. So we've got tools here with data access. We're going to tell it to go and grab the schemas, compose SQL using the data that's coming back from the tools. And we've got various constraints on there and things like that. And you can tell it, this here is how to use the code interpreter, and there's instructions on there, how to format and localize data. So you're effectively giving the agent a personality or a persona, how it's going to do. And this is where that's defined. It's the same as the OpenAI system prompt. Okay, so we've got that. So those are the instructions. And then down through here, we've got MCP tools. So these are called tools, and they're part of the SDK and part of the agent service. So this is a MCP tool, and you give the MCP tool a label. In this case, it's called the Sales Analysis MCP Server. And we've got a bit of configuration information, and these are the tools that are allowed. So we're allowed to get multiple table schema, execute the query, and remember there's that one there about getting the date and time. Now, I'm sure you know by now that MCP servers support both standard I/O and streamable HTTP. So in this demo, I'm actually going to do a little bit of both. Now, for when you're developing these things, it can actually be quite handy using standard I/O mode, but it's absolutely not something you would ever do in production. And the way this is done using MCP is using the agent services, is effectively what we're doing is we're mapping the MCP tools into function tools. So function tools, if you're familiar with OpenAI, basically just mapping that JSON through and telling the agent saying, hey, look, these are some tools. And then behind, there's a bit of Python code, which effectively maps that function call back to an MCP call, then back to the MCP server. But in production, you would absolutely not do it like that. You would do it with HTTP streamable, and you would deploy it into a container and put it into Azure. But for performance reasons, particularly while you're developing these things, it can be quite handy. So the MCP server that I'm going to provide access to, it's a hybrid MCP server. It does standard I/O and streamable. So what we're going to do is we're going to kick off and start the service, the agent and the MCP server in standard I/O mode. Okay, so that's now running. Let's now firing that up. And what I'm going to do is we're going to pop across and we're going to go into the agent. Not that one. Hopefully that one there. Okay, cool. So this is the agent, and that's now running that I've just kicked off. The other screen or debugging was for the web client. Okay, so we've got our web client over here. What we're just going to do is clear that out, and we're going to ask the question. We're going to ask a question here, sales by store. And you'll see what's happening. I'll just make this a little bit bigger. Is that the agent kicked this off. So the agent is kicked off effectively a runner, and it's queued, and then that goes, and then eventually that thread and that run, it becomes queued and then executes. So it becomes in progress, and then there's action required. And the action required will be, hey, look, I need to go and get the table schema. So you can see one up here. The action required here was to get the table schemas. And then the large language model got the schemas back. Then the next action required was to go and execute the query. And you can see here, I know it's not the easiest to see, but you can see there goes my select statement. And that was what was executed. And that's how the data's come back. Okay, so what I'm going to do now is show you how you might want to go and do this in a real environment. Now, I'm going to kick off another set of apps to support this. So what I'm doing now is I've started the MCP server in HTTP streamable mode. Now, you might be wondering to yourself, well, why did you just do that in the first place, given that you're going to want to deploy it like that? And that's a valid question. The reason you probably want to do it is that there is a performance overhead. Now, the way that this works is that the agent service is obviously, or maybe not obviously, but it's a cloud service. And I'm running the MCP server locally. So somehow I need to be able to tell the agent service to call the MCP service on my local system. Now, the way that I'm doing that is I'm using a dev tunnel. So that dev tunnel is effectively saying I'm effectively making my MCP server appear as if it was a cloud deployed MCP server, but it's not, it's local. And why that's useful is it means you can obviously go and debug it and put breakpoints into your code and things like that. So in fact, why don't we do that? We'll come over here and we're going to put in one for getting the schema. So we'll put a breakpoint on there and we'll clear this chat. And what I've got already is I've set up a tunnel. Now, hopefully that's still running. And if it's not, we'll have to restart it. And I'll do sales by store. We'll pop back over here. And apologies for the lack of screen real estate, but this is not the easiest demo to do when you don't have a lot of screen. Now, okay, so that is working, and you can see there's quite a performance overhead of it having to make, okay, the reason it stopped, you're probably all screaming at me saying it stopped at the breakpoint. So we'll step over that and we'll step into our MCP server. So we've got grabbing our MCP server, step through that. And for this case here, it's closing the database and it's returning back the data back to the large language model. You can see that the MCP server return back, execute that command there. The response is timed out now. Sales by store. Hopefully you got the general gist behind what's going on. But the key thing here is if you're doing HTTP streamable and you want to be able to debug locally, you need to set up a dev tunnel. Okay, so we're rapidly running out of time. Now, all the code is available at this link. So if you come across, so grab a screenshot of this or use a QR code. So just grab a screenshot and all the source code you'll find for that demo, the MCP service, the agent code, how to deploy it, and the documentation. Now, a fairness documentation is still coming together, so give it maybe a day or so for you to check that out. Okay, so are there any questions?
One of the number one questions that we got was, where can they get the code? And of course, you just put it up, which is fantastic to see. One question that people had specific was, how do you kind of define like agents versus like what the difference between an agent and like an LLM with tools, for example? Like, what are the different use cases that you see in defining those two differences?
So an LLM with tools and an agent. Well, I think that's probably almost a definition of an agent. So I guess it's the way to think about an agent. Well, if you think, maybe I'll step back. If you think about the way that which you might have gone built a traditional application, and a traditional application, it could be a Mac OS, a iPhone, a Windows, whatever it is application, then as a developer, we would go through the process of defining the logic for how that application works. What's different for the world of agents is you're effectively delegating that responsibility of orchestrating all the parts of this application that you might have traditionally done as a developer. You're saying to the large language model, here are some tools. Here is how I want you to behave. Now you figure out how to plan and how to coordinate all those tools to ultimately meet the goal of the in this case the question. So I don't know if that's the way to think about it, but that's the way I like to think about it. Is you're effectively telling the large language model, you are responsible. I'm going to give you some guidelines. I'm going to give you tools. It's up to you to kind of figure out all the pieces, all the moving parts that you need to go and do to ultimately answer that question. So I don't know if that's a way of describing or answering that question, but hopefully that's clear as mud.
I think that's pretty good, I think. All right, one really quick one here for you. What would be some of the benefits of using the Azure Foundry Agent SDK over like something like Semantic Kernel? Or when would you want to use each?
Great question. And for the interest of time, I did skip over some of those things. So the goal of the agent service is to radically simplify your developer experience. So when you go and look at the code for building an agent service application, you almost look at it and think, well, where's the code? Because there almost isn't any. Obviously, you have to deal with the user interface. In this case, I had to deal with that web UI and things like that. So there's a bit of code in there. I did a bit of code for mapping functions across to the MCP server. But by and large, there isn't a lot of code. So the agent service is dealing with things like context windows. So you can go and define various heuristics. How do you want the context? How do you want the agent service to manage the context window? Because obviously, as a conversation is going and growing, you've got a context window on that thread, which is getting larger and larger and larger. At some point, that context window is not going to fit inside the context window of a large language model. So the agent service will manage that and make sure that the context is pruned down to a sufficient size for dealing with all those types of things. Again, it's responsible for calling out tools and those types of things. So things like memory management, security, those are the types of things that you just kind of get out. Whereas semantic kernel, the other thing is the agent model. Actually, that's not even entirely true nowadays either. I'll skip that. Whereas semantic kernel is a little bit like LangChain or those types of things, where you're having to deal with a lot more of the logistics and the code and the various frameworks that you're kind of responsible for running those with inside your application that you need to kind of manage. So you're effectively outsourcing and making it much simpler to go and build an agent using the agent service. So hopefully that's a reasonable definition of why you might want to choose one over the other. The semantic kernel might just give you more flexibility. But you can do an awful lot with agent service out of the box.
Perfect. That's awesome. Thank you so much, Dave. I really enjoyed your presentation. Thanks everyone for tuning in, and have a good day, Dave. Appreciate it.